So I'll be discussing a very basic topic in chemistry, which has very tiny details in which students get mixed up. So atomic structure is my today's topic. And since I'm taking class 10 chemistry, so the whole book is my syllabus. So I have chosen chapter 3 from there. So atomic structure, obviously it is going to talk about atoms. But before we know what an atom is, we would like to know what is an element. Now, element is a substance which cannot be broken down into anything simpler by chemical reaction or chemical methods. So like carbon is an element, oxygen is an element, sodium is an element. So these substances cannot be broken down into anything simpler with the help of chemical reactions. Okay, so now elements are made up of atoms. So if I break down an element physically by applying force, if I'm breaking it down, the smallest particle that I will be left with at the end will be my atom. So I can say that atom is the unit of an element. Since we have a biology teacher, she'll understand if I say it like this, like cells are the unit of living organisms, right? Just like that, atoms are the unit of so that would make it a bit more clear. Okay. So here the book defines it like this: an atom is the smallest piece of an element that can be still recognized as that element. So even if we have an atom, we can call that it is the atom of that particular element. Now, when we know about atoms, we also need to know about molecules. Basically, most solid objects are made up of atoms, like whether it's our chair, table, any non-living thing, even the salt that we take, they're made up of atoms. But what are molecules? Like the gaseous substances usually exist as molecules. When two or more atoms get chemically combined, they form a molecule. As it is shown in this figure, you can see in figure 3.3 part A, there are two H. H is the symbol for hydrogen. Now, one H indicates one hydrogen atom. So when one hydrogen atom bonds with another hydrogen atom, it forms H2 molecule. Now, this H2 molecule makes up hydrogen gas. So any sample of hydrogen gas is made up of millions of H2 molecules. Now look at part B. It is H2O. This is the formula for water. So the water that we're always drinking, using for cooking, for taking shower, whatever. Water is a basic necessity for life. That water has the formula of H2O, and that water is made up of millions of H2O molecules. Now the difference between these two is, in figure A, hydrogen molecule consists of the same element. So both the atoms are of the same element, hydrogen. But in water, there are two different elements here. So one is hydrogen, H, and one is oxygen, O. So molecules can be formed from same element atoms or from atoms of different element. But whenever it's more than one atom, chemically combined, it's a molecule. I hope it's clear to everyone up to this. If anyone has any question, you can ask me. You're most welcome to ask. Okay, then I'll move forward. Now let's look at the structure of a single atom. As I said, atom is the unit of an element, just as cells are the unit of living organisms. So I have told earlier that if I break down an element, the smallest particle I will be left with is an atom. So an atom cannot be broken down further chemically, but there can be nuclear reactions which can split an atom. but that's part of physics, so I'm not going to that. Faria will know better. So I will talk about what's there in chemistry. So in one atom, every atom has a generalized structure, which is shown in figure 3.4. So at the center of an atom, there is something called nucleus. Cell যেমন nucleus, atoms also have nucleus. So the center part of an atom is the heaviest part. I mean, most of the mass of the atom is concentrated into the central nucleus. This nucleus contains two different types of subatomic particles called protons and neutrons. Okay. And around the nucleus at definite distances, there are electron shells. Okay. These are like, usually we draw it as circles around the nucleus. These electron shells hold electrons, which is the negatively charged subatomic particle. In the nucleus, the proton is the positively charged particle, while neutron is neutral in charge. I mean, it has no charge. So as a result, when the number of protons is equal to the number of electrons in the atom, the overall charge of the atom is neutral. Suppose if I take an example of what atom? Like, let's see, aluminium atom. Aluminium is a metal. Aluminium has 13 protons, and it will also have 13 electrons arranged in different shells. Now, since proton has plus charge, positive charge, so we can say that plus 13 for proton. And since electrons have negative charge and the number of proton is always equal to the number of electrons for an atom, we can say minus 13. So plus 13 minus 13 cancels out, and overall charge is 0. I mean neutral for the atom. Here we have a table which shows the name of the three subatomic particles: proton, neutron, electron, relative mass and relative charge. Now we should focus on the word relative. Now this mass is not the real mass like in milligram or gram. It's just a comparative mass. Then the relative charge is also like that. Now proton always is considered that one proton has one positive charge, and one electron has one negative charge, while neutron has 0 charge. We can see the relative mass of proton and neutron is 1, while electron relative mass is 1 by 1836, which we can consider as negligible. So the electron is nearly massless. So that is why all the mass of the atom is concentrated in the central nucleus, which contains proton and neutron. Then we have certain terms that are very important in chemistry while studying the atomic structure. That is the atomic number and mass number. Now, I have talked about number of protons, right? So this, the total number of protons in any particular atom of any particular element is known as its atomic number. So now this atomic number is specific for every element. Like atomic number of magnesium is 12, atomic number of aluminium is 13, atomic number of potassium is 19, atomic number of oxygen is 8, but they're fixed for every single element. Aluminium cannot have the atomic number of oxygen. Hydrogen cannot have the atomic number of nitrogen. So all these elements have fixed atomic numbers. So the atomic number gives the identity of the element. So if we know that unknown sample of element is made up of atoms with atomic number of 12, we can see that that element is magnesium, because 12 atomic number is only specific to magnesium element. And one kind of element is made up of only that type element's atoms. Like magnesium is made up of magnesium atoms only. So here you can see that the number of protons in an atom's nucleus, it's called its atomic number or proton number. So atomic number equals the number of protons. Now, what is mass number? It has another name or the nucleon number. Mass number is the number of protons plus number of neutrons. That means if we add the total number of protons and the total number of neutrons present in the nucleus of an atom, I can get the mass number of that atom. If we look at an example that would be more clear, I guess. This is how elements are arranged in a periodic table. Since we have time limitation, I cannot show the periodic table today, but maybe if I get another chance in the next session, I will definitely try to show it. So periodic table basically arranges all the elements discovered till now according to their atomic number, according to the order of increasing atomic number. So now this is how the elements are recorded in the periodic table. They have a symbol. Every element has a chemical symbol, which is its identity. Now, CO stands for the element cobalt. All right. Other words, we can say cobalt has a chemical symbol of CO. So this is also specific. Now, CO is always cobalt, never anything else. Now, this is 59 at the top and 27 at the bottom. What does these two numbers mean? Now, in some periodic table, these numbers can be swapped. I mean, it can be like 27 at the top and 59 at the bottom as well. So when I tell my students, I tell them do not look at the upper number, lower number. Always think that the number with the largest value and smallest value. So the number which has the smallest value will give you the atomic number of that element, and the number with the bigger value will always give you the mass number of that element. So can anyone tell me what's what atomic number for cobalt? Firdaus sir, can you try and tell me what's the atomic number of cobalt?
27.
Miss, it is better not to ask me because I don't want to disappoint you.
No, I will be disappointed at me. I mean, I will be disappointed with myself.
You are good at what you are doing, but I'm not good at what I'm doing.
Okay, sir, I thought that the question was easy. Anyone?
Yes, you are good at that, but I'm not.
Okay,
It
sir.
is 27, isn't it? Yes.
Yeah, it's 27. Atomic number is 27. So what will be the number of protons in cobalt?
Then 59 minus 27 it will be.
No, miss. A number of proton is always given by the atomic
Oh,
number.
yeah. So
Atomic
the
number.
27 will be the neutron will be the actually 59 minus 27 is the neutron number, and proton number is 27.
Yes. So atomic number and proton number is always same. So 27.
Always same, yeah.
And proton number in case of cobalt element. Now 59 is the mass number, which includes both proton and neutrons.
And neutron.
I know the proton number is 27. So if I want to find the neutron number, I can just subtract 27 from 59. And the result will give me the number of neutrons present in the nucleus of one cobalt atom. So any questions from this? Here you can see that number of neutrons equals to mass number minus atomic number. Before ending, I would just like to talk about isotopes. Now, we have a sample of hydrogen gas. We can say that it is made up of hydrogen molecules, right? But there are some atoms of the same element which will have the same number of protons but different number of neutrons. That means their mass number will be different, but their proton number will be same. Such atoms of one single element are known as isotopes. So here it's defined like this. Isotopes are atoms of the same element which will have same atomic number but different mass numbers, which means they will have different number of neutrons. The example of carbon is given here. These are the three isotopes of carbon. See, all have 6 protons. Okay, the atomic number is 6 for all. Because if the atomic number changes, the element is going to change. But the mass number is different. This is first one is carbon 12, second one carbon 13, third one is carbon 14. So what is changing? The mass number is changing, As a result, the number of neutrons is also changing. So in the first one, number of neutrons was 6. In the second isotope, it's 7 neutrons. In the third isotope, it's 8 neutrons. So due to the change of neutrons, they are forming isotopes, but this will not affect their chemical properties. That means the way they react or the way they perform in chemical reactions will stay the same. Why? Because they have the same number of electrons. Electrons are those particles responsible for chemical reactions, or those particles which take part in chemical reactions. So since all have same number of protons, they will also have same number of electrons. So that's why, since the number of electrons do not change, their chemical properties also do not change. So that was all I had to present today. I would welcome you to ask questions.